I'm Elijah Hobbs. I'm a third year from Warner Robins, Georgia, which is home to the Robins Air Force Base, which actually has nothing to do with why I became an aerospace engineer. I grew up around a crap ton of planes and helicopters and didn't really find them all that interesting. I loved space ever since I was a kid. I kind of just looked up and was like, that keeps going. That's terrifying. I want to know why that is. And so I got really interested in space exploration, space research, a lot of stuff with NASA, rocketry, satellites. I just loved all of that stuff since I was a kid and wanted to learn more about it. And I did when I was a kid. And I was like, that'd be cool to do when I grow up. Kind of forgot about it for a while. And when I was a senior in high school, I was like, good in math and science. That's the rocketry is cool. Might as well do that if I'm good at math and science. So I became an aerospace engineer. Ever since then, I've kind of rethought some stuff. I still like space exploration. Obviously, it's really cool. But I've been thinking more about doing stuff with wind turbines and renewable energy, just because they look really cool. I just think they're cool. It'd also be cool to do stuff with energy production and be able to help with climate change. I think that'd be a good use of my talents, and I think that'd be cool. Onto the dynamics problem. I thought we might get a little crazy, get a little silly. What if, hear me out, we sent a giant, hypothetically, we sent a giant T-shaped rocket aimed at UGA main campus. So essentially, you'd have a bunch of fuel storage all throughout the giant T, and then a single big thruster at the bottom. Now we'd launch this at a 45-degree angle off of Crossland Towers. And we'd have to cover roughly 65 miles getting from Tech to UGA, so we'd have to cross that distance. So I think one of the main problems is determining how much thrust you need to get from Tech to UGA, and also how much to give it each portion throughout the flight. Would it be better to give it consistently? Do you need to have less thrust as you go on because you're going to be losing mass throughout the flight? So I do think this would be an interesting dynamics problem to solve throughout the course. I think that'd be pretty fun, and that's a good enough introduction to me.